Hi students, I wanted to go over an example for the animal behavior analysis of data for Bio 153 using an example data set. And remember that you're going to be using your Part 3 data for the actual chi-square analysis. And as you can see here, I have this table filled out. These are data that I just made up. So your data may look very different, but for purposes of illustration and to go through an example where I actually calculate chi-square, these are the data that I'm using, and I'm using data that seems to support the fact that the pillbugs are preferring one area over another. So as you can see in the dark dry area, there are consistently more pillbugs there than there are in the light moist area. So that would lead us to believe that yes, the pillbugs are showing a preference. And the way that chi-square analysis comes in is it's an objective way to determine, whether or not our instincts are correct. And if your data aren't as clear as this with showing a pretty obvious preference, it's a very useful tool in saying either yes, they are showing a preference, or no, they are not showing a preference. So keep in mind that the null hypothesis is one of no relationship between the variables. And if the null hypothesis is true, that means there is no preference. There's no evidence to say that the pillbugs are showing a preference for one area over another. Okay, so let's walk through the chi-square calculation here with these data. Complete the following steps to calculate your chi-square statistic, and remember to show your work on this. So you can show it as I have here. So number one is calculate the average number of pillbugs in the dark dry area. So what you want to do there is add or sum the first row and then divide by 12. And I will say you want to be careful when you do this on your phone or with a calculator, because if you just enter this all in a big line together and put divide by 12 at the very end, there's going to be an order of operations issue, and that may give you an incorrect answer. So what you want to do is add all of your number of pillbugs at each time interval, enter that, and then divide that by 12. So as you can see, we have the data from this table for this dark dry area, 7 plus 8 plus 8 plus 7, all the way to the end there till 10, and that gives us 105. And then we take 105 and we divide that by 12 because we're just getting an average of how many pillbugs are in that dark, dry area over the course of that 12 minutes. So our average is 8.75. And then number two, calculate the average number of pillbugs in the light moist area. Again, we're just referencing that Part 3 data table. Starting with 3, we're going to add all those numbers together. So we do that here, it equals 15, and then you're going to divide 15 by 12, and you get your average number, which is 1.25. And it's okay, I know it doesn't make sense to have a quarter of a pillbug, but it's fine mathematically to have that fraction there. So our average for that is 1.25. I forgot to put this in red as well. So 8.75 is our average for dark dry. 1.25 is our average for light moist. And then number 3 just asks you, how many pillbugs would you expect to be in each chamber on average if they display no preference? If they display no preference, we would expect there to be 5 on each side at every time interval, because they're clearly not congregating on one side or the other. They're not showing a preference. Number 4, for each environment, take your average observed result and subtract your expected result. So again, you're using your average, your observed, minus that expected of 5 for each environment. We're squaring that, and then we're dividing that by our expected. I apologize for the rabbit noises. And this separated. Okay. So for our dark dry, we have that average average observed 8.75. We're subtracting our expected of 5 from that, then we're squaring it, and then we're dividing it by 5. So we get 2.81. And then for our light moist environment, our observed average 1.25 minus 5, square that, divide by 5, we get 2.81. And then we sum them. And I realized that this could have been worded better. All the values, there's only 2. Sum the values. So 2.81 plus 2.81 equals 5.62. That is our chi-square statistic. Okay. Now we're going to use our chi-square table to determine what we do regarding our null hypothesis. So our significance level is 0.05. That's what's known as an alpha level, 0.05 or 5%. And with our 1 degree of freedom, since there's 2 choices and calculating degrees of freedom, 2 minus 1, it gives us 1 degree of freedom. The magic number here is 3.841. What did we find again? We found a chi-square value of 5.62. So, 5.62, is that higher than 3.841 or is it lower than 3.841? It's higher, right? It's within this significance area. It's very close to 5.024, which corresponds with the alpha level of 0.025. So if your chi-square value is 3.841 or higher, you reject your null hypothesis. And again, what does that null hypothesis mean? The null hypothesis is one of no relationship. So if the null hypothesis is true, there's no preference between those environments. But in this case, we do have evidence to suggest that the null hypothesis has not held up because our chi-square value is greater than 3.841. And another way to think about this is the larger your chi-square number, the more of a difference there is between what you observed and what you expected. So that's also going to lend support for rejecting the null hypothesis, and on the flip side of that, accepting an alternative hypothesis, which states that there is indeed a preference. All right, so I hope that was helpful. Please let me know if you end up having any questions about this, and I'll see you in class.